So in part B1, we're given this cell setup, and we're given that the reading on the voltmeter is 1.2 volts. We need to determine the internal resistance of the cell. So we know that the EMF is equal to current times R plus small r. And what we also know is that the internal resistance is equal to the voltage over the current across this internal resistance. And we know that that will be 1.2 volts simply because there's 1.2 volts across this component. So what we can do here is simply rearrange this equation a little bit so that we get that the current is equal to the EMF over R plus small r. And we can use the fact that V is equal to I times R from this equation. So V is equal to I times small r to make it look like V is equal to EMF over R plus small r times our current. And so, well, we know everything in this equation. We know the voltage read off. We know the EMF is 1.5. We know, well, pretty much everything. Only that here we need to have a small r. That is why we have rearranged this also. This is the current that we know. We plug that simply into here. So we know everything here. We will find that the internal resistance is 1.25 ohms, simply solving this equation. In part B2, we're told a second 5 ohm resistor is connected in parallel to the first resistor. And we need to state, if any, the change in the voltmeter reading without calculating. So what we see is that we added a new resistor, and therefore the R total decreases because they have been added in parallel, which means that considering the EMF has to be constant, the current has to increase. Since we have a smaller resistance, which means that if we have a larger current, we will have a larger potential drop across our internal resistance, because the potential drop across this component is simply V times I times small r. So we lose more potential across our internal resistance when our current is larger, which means that the useful voltage of the battery is going to decrease because it will have to use more energy to drive current through its internal resistance, and therefore V will be smaller, less available, and there will be less potential available for the rest of the circuit.